And let's just kick into things. So, hi everyone. Again, my name is Andrea Brandon. I'm the Science Delivery Specialist with the Northern Research Station, and it's my absolute privilege to welcome everyone today. So, Fueling Collaboration is a panel discussion series presented by the Forest Service Northern Research Station, Southern Research Station, as well as by the Joint Fire Science Program's Fire Science Exchange Networks. So in the East, so the Consortium of Appalachian Fire Managers and Scientists, Lake States Fire Science Consortium, North Atlantic Fire Science Exchange, the Oak Woodlands and Forest Fire Consortium, the Southern Fire Exchange, and the Tallgrass Prairie and Oak Savanna Fire Science Consortium. Our goal is to bring together researchers and managers to learn about and to discuss the latest in fire science and application, as well as to build collaborative opportunities across the region. This is the third installment of our 5-part series this year. And our discussion today is titled, Smoke is Not Just Smoke. So what is it then? We have a pretty stellar lineup of panelists that will unpack this topic for us. And our moderator, Jack McGowan-Stinski, will soon introduce them. But before we go on, I'd like to first acknowledge the organizers of this event. So each person listed here, Jen, David, Craig, Virginia, Joe, Stephanie, Amanda, Jack, everyone has contributed their expertise and their time to making this event fun, exciting, and informative. So I just want to say a deep appreciation for all of our organizers as part of this panel. So this is, as I said, a 5-part series. We invite you to join us for the next 2 discussions that will wrap up our series. So in February, David Gowan will be moderating a discussion on fire and wildland urban interface in the East. And then Jen Bunty will close up this year's series with a discussion on thinking beyond fuel reduction. And so that discussion will focus on some of the benefits of prescribed fire that go beyond fuel reduction. So touching on burning for tick control, blueberries, or rare species habitat. So at this point, I'm going to stop talking and pass it over to you, Jack. You have the floor.
All right, folks, welcome to Fueling Collaboration panel discussion on smoke, or as we dubbed it, smoke is not just smoke. We want to tease out all the different aspects of smoke. And again, Andrea introduced me from the Lake States Fire Science Consortium and as the moderator. But let's get right to our panel of smoke experts. And I'm going to ask them to kind of briefly describe their expertise in smoke so we kind of have a frame of reference of where they're coming from when they're answering questions. We'll start with Trent.
Yeah, impressed by how many people showed up to this. Hoping that we give you a good show today. My name is Trent Wickman. I work with Forest Service. I've worked as a full-time air quality specialist since 2001. Entirely in the Lake States. I'm located in Duluth, Minnesota. I work across Minnesota, Wisconsin, Michigan primarily. Before that, I worked for the State Air Regulatory Agency in Minnesota for 5 years doing industrial air permitting. So when I came over to this job, I had no experience at all in smoke, and I've really enjoyed getting up to speed. And since 2014, I've also served as an air resource advisor going out on wildfires. And over those years, I've hit most states. So I have a good perspective on how other states operate and do smoke management too. That's all I have.
Thanks, Trent. Lida?
Hi, good morning, everyone. Thank you for joining us. I'm Leda Kobziar. I am Associate Professor of Wildland Fire Science at the University of Idaho. And prior to that position, I was in the South for about 10 years at the University of Florida. I'm a fire ecologist, a pretty broad generalist in terms of the things that I'm interested in with regards to fire ecology. But in the past couple of years, I've been focusing on what we call pyroaerobiology, or the study of life in smoke. And I've been trying to become a microbiologist in a short amount of time and have learned a lot about fire science. I am going to enjoy this conversation and learning from my colleagues here in the panel, and hopefully can bring something to the table about the biology of smoke as well. Thanks for having me.
Thanks, Lida. Melanie?
Everyone. So my name is Melanie Petrollo. I am the Regional Air Program Manager for the Southern Region of the Forest Service. So that is from Virginia to Texas. And I sit in Asheville, North Carolina. Prior to my involvement with the Forest Service, which began in 2008, I too, like Trent, was an air environmental engineer focused on air quality and air pollution with state regulatory agencies. So my focus prior was on industrial pollution and impacts to public health. Since 2008, though, when I joined the Forest Service, I have been focused on, part of my work has been focused on smoke management and the impact that our smoke from prescribed fire activities particularly have on nearby communities. But recently, I have become more and more interested and perhaps concerned about the impacts to firefighter health and safety as well. So I hope that we can get more into that topic today, along with just general what is smoke and what we can just be aware of when we're doing this important work of prescribed fire on the landscape.
Thanks, Melanie. And Jay?
All right. My name is Jay Charney. I started with the Forest Service the same year that Trent did, so our careers parallel in certain ways in 2001. I'm a research meteorologist with the Northern Research Station based in Lansing, Michigan. And my background is as an atmospheric modeler. So I run the models that are used to predict weather on a day-to-day basis in a research mode to investigate fire weather and smoke applications. And part of the reason why I'm on this panel is kind of talking about how those models can help inform smoke dispersion, smoke and smoke concentrations, and also what sort of information we get from the Weather Service and from the meteorological community that helps inform smoke-based decisions. And so I'm going to be talking about modeling things and researchy things, but trying to keep us grounded.
Thanks, Jay.
Keep me grounded. So thanks.
All right, well, let's get right into it. As Andrea mentioned, we've gotten a lot of questions from registrants, and we took those and sorted them roughly into 4 categories. And you can see the categories and breakout here. What exactly is smoke made up of? Are there differences in smoke, whether it's from wildfire, prescribed fire, brush piles, slash piles? We had a lot of questions that are focusing on smoke impacts to human health, both public and firefighters, and then the whole social dynamics around smoke, and then quite a bit on smoke modeling and smoke management. So before we get into the individual questions, I want to leave you with this smoke meme to start us out. And one does not simply avoid smoke from a fire. So we often hear about fire, whether it's wildfire, prescribed fire, and we're thinking of fire, but people often forget about smoke until it becomes some type of a nuisance. So let's delve into this. I'll stop sharing the screen, and I'm going to start out by asking Trent, and then the rest can fill in. But Trent, can you give us a little background? What is smoke made up of?
Yes, again, anybody on this panel could do an equally good job, but I'm going to give it a crack here. Start with an analogy. I think that helps me, anyways, think about this is I think pretty much everybody has experience with a campfire, and if you notice when you have a campfire, how you start out, and once you get the fire really going, that you will have not as much smoke, or a little bit of smoke, but not a lot. You got a good efficient fire burning. As the fire dies down, you can see the smoke start to increase, become thicker, more volume of smoke. And a lot of times people learn that to fix that problem, they can blow on it, and that will cause the fire to pep up again and become more efficient, and you have less smoke. And so if you think and translate that out to the ground and out to the forest or wherever you're burning, out to the tall grass prairie, and think about all those little chunks of wood that are out there, or grass or whatever. If it was a perfect world and we were burning that fuel in, for example, like an industrial boiler or some other engineered system, we would be moving more towards the ideal situation where if you burned that carbonaceous material, it basically would just get water and CO2. But the world is never perfect. And so what we end up getting is a situation where we have what's called products of incomplete combustion. So you have a lot of things that are formed that it didn't burn efficiently. And so you have things like carbon monoxide, you have lots of carbonaceous chemicals of all different types. We talk about particulates that can be formed from gases that come off a hot fire and condense later into particles. So you basically have hundreds, if not more, maybe even thousands of chemicals that come off a fire. And it's really just because the fire is not burning as efficiently as it could be. So I don't know anything about the biological part of fires, though, so I'll be very curious to learn about that myself. But that's my start at it.
Others want to
Alright.
jump in?
Yeah, well, I'll jump in just briefly here, and I'll say right off the bat, I am not a chemistry expert by any stretch of the imagination. I know enough to be dangerous at times, but in doing a little bit of background reading and sort of getting some ideas about what we might talk about today, and several of you might have had this in training classes over the years, is that when fires first start, oftentimes the smoke looks quite white or quite lighter in color when fires are first getting started. And that mostly, as I understand it, is to do with the evaporation of the water that's part of the fuels, and sort of the initial part of a fire usually have very white smoke, and that's indicative of a young fire, if you will. And then as the fire evolves, it evolves into different colors depending on how efficient the combustion is, as Trent was talking about. And that's when you get into more of the gray and the black smoke can be extremely inefficient burning or extremely dense fuels. And that's my understanding of visually what you're seeing when you see smoke.
And if I may jump in as well, just to add to what has been said so far, which is great. So the two main pollutants that we're most concerned with from a human health standpoint in smoke would be carbon monoxide and fine particulate matter. Now, carbon monoxide is generated really close to the fire because of this inefficient combustion that Trent and Jay talked about. It dissipates rapidly as you go away from the fire. So it's not a concern for nearby communities, but it is a concern for firefighters that are on the ground. The fine particulate matter, those are the really, really tiny particles, PM 2.5 microns. That's the diameter of the particle. So as an example of what that might mean, the diameter of a human hair is about 70 microns. So we're talking really, really tiny particles can get deep in our lungs and cause a lot of health concerns. So that is a concern for both firefighters as well as nearby communities.
And maybe I'll chime in about the biological aspect of smoke. So for really just the past handful of years, we've started to measure and quantify what kind of organisms are also included in smoke particulate matter. And it turns out that there are thousands of them. They are bacteria, they are fungi, they depend on what kind of fuels are being consumed and how fire behavior looks. And of course, how much mixing is occurring in relation to ambient air characteristics. But what we're finding is that the concentration of these organisms in smoke is a number of orders of magnitude higher than the background concentrations. So there are always organisms in the air, bacteria and fungi both, and that's just part of the air that we breathe. But the concentrations are much, much higher in smoke, and the things that we find in smoke are also very different from what we find in background air characteristics. So we're kind of at the beginning of understanding what this could mean, but there are a lot of these organisms that have the potential to have effects on ecosystems downwind, on people who are breathing in the smoke, on crops, et cetera. So that's kind of where the biological aspect comes in, and we're estimating that in typical conditions, let's say an understory burn, a prescribed fire burn, the percent mass that these organisms comprise is somewhere between 7 and 15% of the mass of the particulate matter. And those are just estimates at this point in time. But it's a good chunk of what's in the smoke and the particulate matter that comprises what we see in smoke.
And you said that it's a relatively new field of study. So that's the pyroaerobiology, correct? Am I saying that correct?
Yeah, exactly. We just needed a word to call it. So we put together, if you put pyro in front of anything, it makes it cool. So.
And I believe, yes, there are different references going into the chat for that. All right, well, excellent.
Jack, if I can ask a question here, and please cut me off if we're going to take up too much time. But one of the issues that I wanted to raise right here, at least one of the questions I had about this, is in some of our earlier discussions between Jack and myself and others. I mean, from a management perspective, in my experience, I've almost always heard of smoke as a negative aspect of a fire. If there were a way we could put fire on the ground and not emit any smoke, it would make putting fire on the ground a lot easier for many, many people. But the research that Lida and others are doing into the pyroaerobiology, I think, affects that assertion somewhat. And I'm wondering, Lida, if there's any sense at this point in these sort of early days of this field of how important these processes are for ecology, and are they positive or negative? Are they? Can one say at this point if we have to sort of rethink the smoke is always a bad thing from a fire management perspective?
Yeah, well, I think the interesting thing is that we are seeing different organisms depending on fire intensity. So certainly we see higher concentrations in characteristics that are more akin to wildfire circumstances like crown fires, for example, compared to understory burns. And I think the really important thing to keep in mind is that the degree of mixing of the smoke with ambient air is typically, and this is a generalization, but is much, much higher during a prescribed burn in relation to the amount of smoke that is being produced and the rate of smoke that's being produced in a wildfire. So I think that the difference in concentrations is going to turn out to be really important. And I'm certainly have always been a very big proponent of prescribed fire. I think that it is an incredibly important part of the toolbox and set of solutions to understanding and living with fire. And as such, I also think that the beneficial aspects of smoke are incredibly understudied. So there are components in smoke like keratin, for example, has recently been isolated that are very beneficial to germination, to sprouting, to regeneration. And we have very little understanding of what that actually looks like in the field. There are also smoke components that are known to control forest diseases and forest pests. Dwarf mistletoe, for example, is reportedly controlled or reduced by smoke depending on the duration of the exposure. So there, I think, are a lot of potential benefits of smoke as well, ecologically speaking. And with regards to transporting organisms, these organisms are also the beneficial organisms that all ecosystems depend on: nitrogen fixers, symbionts, things that are essential for plants to be able to pull in nutrients and water. So, for example, mycorrhizae are being transported in smoke as well. So it's definitely a mixed bag, and I think if we keep in mind that all of the ecosystems that have developed in the context of frequent fire have also developed in the context of frequent smoke for many, many millennia, we should probably assume that there are both positive and negative impacts.
Perfect, thank you.
That's excellent. It's kind of pointing out we always think of smoke as bad, but there are positive effects too. I'm going to actually just change it up just a little bit here in our order, because you did mention, smoke production. Can you guys delve a little deeper into that? So what influences smoke production? Thinking of vegetation, ignition, fuel moisture you mentioned, season of burning. Anybody want to grab that and go?
Start, and I know that others have much more to add to this, but when we're looking at emissions or reduction of smoke from a fire, we're going to look at what are your fuels on the ground, what are the condition of those fuels, are you moist, are they dry, what's the fuel moisture levels, how much of that loading are you planning to consume, how much of the duff layer are you planning to consume. Some people, as part of their prescription might want to consume more of that, and others it's not part of their goal at all as far as the treatment plan. So we look at all those things, we provide a fuel consumption estimate, we apply an emission factor for the different pollutants, and then you come up with your amount of pollutant, whatever that pollutant might be, produced in a tons per acre or a pounds per hour, depending on how you're planning to fire that unit. So that's how we do it broadly. There are lots of tools that are available that we can point you to on actually calculating that. I'll turn it over to others to add.
That was a great introduction. I thought one thing I was going to add to that is, it's somewhat simple math. It's fuel consumption, and as affected by how much is there and the fuel moisture. And I just wanted to make a point in regards to something that I know I've heard just recently last week. Both Melanie and I both taught a higher level smoke management class called RX 410. And the issue came up, and I know this is something Jack has talked about, that there seems to be a fear of, in some quarters, of burning in the growing season or the summer. And this fundamental fuel consumption generates emissions calculation that Melanie just talked about applies no matter what season. It doesn't stop applying in June or July. So I would encourage folks to think hard about if that's some sort of black and white no-go for burning, to think, why is that? Because as Melanie just explained, the amount of emissions is dependent on your fuel loads and your fuel moistures. That doesn't change during the summer. So I just wanted to mention that. That's it. Thanks.
Yeah, and I guess another point I might raise about this, and this is speaking as a researcher, I don't do management myself, but depending on the sort of the goal of a prescribed burn program for a given forest or a given area or a given region, there are potential feedbacks, I guess, to the difference between the amount of emissions you get from a wildfire burning the same patch or burning through an area compared to what you get from the prescribed fires as well. And also the time of year of the emissions. And that was another thing I was thinking about when Lida was talking about the different aerobiological impacts, is that it seems to me burning in the growing season compared to the off season or spring or fall could have very different ecological impacts or forest health impacts or fuel health impacts, if you want, for how all of these interact with each other. And so if the ultimate goal is to reduce the year-round emissions, doing prescribed fires to reduce the potential for stronger, more intense wildfires. And in our part of the country, catastrophic wildfires, like are commonly talked about and commonly occur in the West, are generally not as front and center. I mean, they do happen, but it's not the overwhelming concern in the East and the South, or East in the East, let's say all of the East, as it is in the West. But there is still a factor there in that reducing fuels and having more low intensity prescribed fires and the emissions associated with them, the ecological impacts of that compared to the impacts of the larger wildfires, or generally more intense wildfires, can be significant for the health of a forest. And I think all of these considerations are wrapped up in what we're talking about today.
I think you guys just did a nice lead in then. Let's kind of dive into, we had a lot of questions on the smoke and health impacts, and kind of wrap it around 3 topics with that. So thinking about what does smoke impacts or health impacts mean for like your neighbors or society in general. What does it mean for on the ground, for the firefighters, for prescribed burners? And then kind of wrap that up with thinking about smoke impacts, how it's changed with a changing climate. So kind of that's all wrapping into that social dynamic. So, and I can repeat those, but we had a lot of questions on health issues. So
let me kick it off this time, and then Melanie and others can fill in the blanks. Again, since we just had the class, it's interesting. I think I like short answers, short take-home points. And the take-home point that I always say is the focus on the people that are most at risk, the young, the old, those with cardiovascular respiratory diseases. Start with that. And then when you start looking around out from where you are located, where your burn is, where are those people? And it's pretty easy to start figuring out where your sensitive receptors are if you start with the young, the old, and cardiovascular respiratorily compromised people.
Great kickoff. Another thing to always be in consideration of is what are the current conditions? And I think that sometimes we're focused on our particular burn unit, and we're wanting to make sure it's not impacting, downwind communities, of course, and all. But you also need to know: are there other burns that are happening in your airshed? Are there things that are going on maybe outside of burning that are impacting air quality? So I really encourage everyone, before you even light that match, to check out your air quality forecast for your area to see, are you forecast to already have elevated pollution levels that are going to put those very people that we're trying to protect, that Trent just mentioned, that are already going to put those people in some sort of elevated concern threshold. And we don't want to add to that. So always check out the air quality forecast. A good place to check that out is the airnow.org site.
do you have, oh, go ahead, Lida.
Yeah, I just wanted to add on to that. When we're thinking about the potential health impacts from the biological content of smoke, that really is something that we don't know much about yet. And certainly it's of concern for communities, for immunocompromised people, the young, the old. And also, I think is of course very important to firelighters and firefighters. So I would include those frontline fire workers as part of the communities that we should be most concerned about. And the other thing I just wanted to note is that the duration and the frequency of exposure to smoke also has impacts. So, we tend to think in the present moment about what kind of impacts our prescribed burns can have, but I think it's also helpful to think about the context of what people's lungs have been through in the prior season, for example. And in areas where we see long duration or repeated smoke inundation events, the potential health impacts are different from areas where it's less frequent and there's more time for lungs to heal from exposure. So I think all of those things are helpful in understanding the context of smoke impacts on human health.
So Trent, oh, go ahead, Jay.
Oh, sorry, Jack. And I think this is all great so far. Very interesting information. One thing that I wanted to circle back to a little bit was a couple of the points that were raised in the introduction about the constituents of the smoke. And it's, again, my understanding that recent research suggests that there is, not even recent, ongoing research suggests that there is a strong connection between the particulate matter from smoke, the PM2.5 values that Melanie referred to in sort of the introductory comments, and ongoing respiratory and cardiovascular health of, regional and across communities and that sort of thing. The local smoke impacts, there's recent monitoring suggestions that carbon monoxide is potentially much more important can be much more important for the fire managers themselves than was previously understood. But the PM 2.5 issues are one that affect the wider community and sort of the landscape, if it is what the most recent research suggests. And it's not necessarily that there aren't other impacts, it's just that PM 2.5 has been fairly extensively studied and the connections are reasonably clear as I understand it. And one of the things that I might like to circle back to later, and I know that Trent has a lot of experience with this and we've talked about it over the years, are the tools available for assessing what a given burn or a collection of burns in an airshed, how that could affect PM 2.5 levels and levels of other constituents in that area, and ways of understanding, monitoring, and even contributing to that understanding going forward, I think would be great for us to think about as a community.
I'm just going to pop in really quick. Talking about PM 2.5, EPA has recognized that PM 2.5 is a major health concern, so much so that it is considered one of the criteria air pollutants. It's a pollutant that air quality standards, national air quality standards, are set for PM 2.5, both on a 24-hour basis and on an annual basis. And the Scientific Advisory Committee for the Clean Air for EPA is currently looking at strengthening those standards, making them more stringent for those exact reasons that Jay was just talking about, because it's recognized that it is more and more of a concern. Research is showing that even at lower levels, PM 2.5 causes concern. So that impacts not only our local communities, but our firefighters, firelighters, as Lida said, but also how we're going to continue into the future with prescribed fire operations, particularly given the announcement this week about the initiative to treat much more acres, particularly across the West in the future. So we'll talk a little bit about tools. I know that Trent and I both have some tools to share, but we can continue talking about the health impacts if we want before we get into the tools.
I would just
Boy, this
throw
is
out
wide
there,
open. Go ahead.
just
Okay.
to kind of wrap that maybe, is just, I know there's a lot of fire practitioners, which is great on the call today. And I guess don't hear that as sky is falling. I think a lot of times people, for whatever reason, expect to hear from the air person that they can't do what they want to do. And we're all about causing you problems and putting up sidebars that you can't meet. And really what I see is we're the ones that are finding windows for you guys and trying to understand and the impacts and communicate them again to generate opportunities. So, even in this case, if, and as Melanie said, they have not been able to find a threshold of PM 2.5 exposure where there's no impacts. So when they revise it, they end up taking it down every time. What that's going to mean in reality is that if that comes to pass, is that, and I think everybody in this call knows that we've moved far beyond the point where we can ignore smoke, obviously. And what you just need to do is address it through your smoke management activities, which there are a number of different activities, and especially when you think about firefighter health, you need to think more seriously about rotating crews. You need to think about some of those other things that it's just a way of doing business nowadays. So anyways, I just wanted to mention that.
I'm going to actually continue this and pick on Trent a little bit, because Trent, you've mentioned a number of times, not on this call, but in other discussions about, at least for Region 9 with the Forest Service, the Summer of Smoke 2021, and why it was such a surprise to the public. And it's nice with this fueling collaboration panel discussion because we have the whole Eastern. So I guess I'd like to hear the discussion between sort of northern regions versus the acceptance in southern regions. Because, the Summer of Smoke 2021 northern regions shouldn't have been a surprise, but you referenced that it was, Trent.
Yeah. It was an interesting summer for anybody that was, again, in, I guess, northern part of the East. I can't remember how far some of that smoke from Canada tracked. A lot of times it gets mixed in with all the Western smoke, but yeah, I guess we had a very interesting summer. And the question is, was this an outlier or could this happen again? I was to Montana to visit my son, and it was 107 degrees in July. I just about melted. And then wildfires were starting every day I was there. And then when I came home, there was smoke coating the state of Minnesota, the entire state. I'd never thought that was possible. We just generally don't have that much fire. It was along the scale of things that I'd experienced as an ARA out west. And it really exposed a lack of knowledge. We discussed this in my class last week, a lack of general fire knowledge in at least the lake states, and I would propose probably across the rest of northern part of the east. I know the culture, and I'll let Melanie speak to that, in the south of burning is quite a bit different than it is here. But I had worked quite a bit with my state colleagues in Minnesota, Wisconsin, and Michigan when they were dealing with forecasting and trying to figure out what to tell people. And a lot of the communication with the public, people were asking questions like, why don't they just put the fire out? And this is, shows the complete lack of knowledge, because there were millions of acres on fire in Canada, let alone, there's a lot of reasons people know how Canadians address fire, and nobody's going to put people out to protect trees in the middle of nowhere, Canada, obviously. So, but just this whole total lack of an idea of what fire is about, how fires are fought, what that means, major problems. I mean, we had smoke laid into the city of Duluth, where I live, that was so severe that people were calling the local fire department because they thought their neighbor's house was on fire because of the smell of smoke in their house, which was from Canadian wildfires. And then also there was some larger wildfires in northern Minnesota after that were significant. But so we have a big gap. And, I think a lot of us are aware of that. I mean, we obviously have a big gap in prescribed fire knowledge and telling people why prescribed fire is important, but just to understand fires, period, in where I live is a major gap we're going to have to deal with. And that's going to hamper us until we do a good job at addressing that. So.
Okay, thanks. I'd like to expand this out a little bit and think, because are there difference in smoke impacts, or I guess how have smoke impacts changed with the changing climate? And again, I mean, not picking on Trent, you don't have to answer this, but Trent, you had mentioned just there's an increase in fire history data too. So it's kind of that comparison of past fire and where we are now currently, and thinking about smoke impacts throughout, years, present or so on. So, what's your guys' projection? I mean, how has climate change affected smoke impacts, and what is projection for future?
Well, I don't want to take over your job, Jack, but I was really fascinated to hear Melanie maybe comment on the culture of fire in the South as compared to the North before we move away, because I want to hear that.
Right, and then we can turn it over to Lida as well, because she has experience in Florida, which is completely different from the Southern Appalachians. So in the Southern Appalachian, it's similar to Trent. I think that there's not a lot of burning that occurs. When it does occur, it's, we have to really do a lot of public outreach. And so similarly to your summer of smoke, the fall 2016 wildfires in the Southern Appalachian Mountains really put us on notice, like, wow, this is a big deal. Many of you may have heard of the Gatlinburg tragic fires that occurred during that same time period. But again, Asheville was smoked in, Knoxville, other areas, and it really had people thinking about smoke and the importance of maybe fuels reduction, so that these wildfires wouldn't occur again. Now, the majority, I think, I don't know, but I think a lot of the prescribed fire activities here in the Southern Appalachian Mountains are, for ecological benefits, not so much for fuels reduction, but after those wildfires, we really started talking about that and using that situation to try to really do more education on the role of prescribed fire broadly. Now, in other parts of the South, particularly when we get into the coastal plains, into Florida, Arkansas, they do a lot of prescribed burning. It is much more commonplace and very few complaints from the general public. But I'd like to hear Lida's perspective from being down in Florida.
Sure. No, I think you covered it really well. The culture of prescribed burning in the South is unlike anywhere in the world, I think, and is something that has and continues to inspire me in everything that I do. And it wasn't, something that just came out of nowhere. It took a really concerted effort from a group of individuals who took fire into their own hands because they recognized that that was the choice, either that or have fire dictate what happens to their lands. And organizations like the Tall Timbers Research Station, for example, and at least in Florida, the Florida Forest Service and former Division of Forestry, that those organizations came together to not only develop the science that supports prescribed burning use, but also to develop the public outreach approaches that could best educate the people who are impacted by smoke. And I think that those public outreach campaigns that have been in place now for many decades were really critical in getting the public behind prescribed burning, and that's made a huge difference in terms of what people are able to do. But I remember when I first came to the South and went through the training process to become a certified prescribed burn manager in Florida, that the mantra was own your smoke, own your smoke. That everyone is responsible for the smoke that they create. Everyone is responsible for modeling what will happen to it, how it could potentially interact with other people's smoke plumes. And so the cooperation, I think, that is critical for success across agencies, across land ownership boundaries, among private and public practitioners. Those networks, I think, have enabled a collective effort towards managing smoke that has been really successful in the South. But again, it wasn't just magic that made it happen. It was a tremendous amount of effort from a number of different types and entities of organizations working together to create the practices that ensure that the public isn't negatively impacted by smoke. I think this might be a good place to pass it over to Jay too, because there are also obvious meteorological differences across regions. And with flat topography and water on both sides, on all sides, at least of the peninsula of Florida, there's a high degree of mixing. And whatever air mass is over the central part of Florida, it doesn't stay there for very long. So there are some really important meteorological differences associated with topography that make smoke management very different in different regions.
All right, well, Lida pinged me on that, so I will agree absolutely that smoke management and smoke concentrations and dispersions can be highly regional dependent, seasonal, and even day-to-day weather. The difference between Tuesday and Wednesday could be significant in many cases, and that's why we have spot forecasts to help try to inform those sorts of things, and the other array of tools that are available to people. So that's definitely part of it, and I agree about the sensitivities there. And I guess maybe to amble towards Jack's question about climate, one of the points that I might raise there is that, and I certainly don't want to come across as a climate skeptic or a climate denier in what I'm about to say. Climate change is I completely accept that it is real and it's happening and it's something that we need to contend with, but we have to be very careful, and some meteorologists are more careful than others. I'll say this about attributing individual events to climate. So sometimes there is a clear climate signal, but other times it's less clear, but people will say there's a strong climate signal anyway. And that is a real phenomenon within my discipline. And I think that applies to fire. Saying that this fire was caused by what was made worse by climate change is kind of difficult to defend for any given fire. But saying that we had 100 fires in a region over this season, or some multiple of fires in a region over a season, that's more talking about climate signals. But when the difference between whether a fire is severe was whether it happened on Tuesday or Wednesday, it's very difficult to argue that that's a climate signal. So it's like it's a very complicated multi-scale problem. So that's where it gets into difficulties. I think one could argue reasonably convincingly that this past summer that there was a climate signal to all kinds of records that were set as far as temperatures, moisture, and conditions across the West and across Canada, where you could argue there was a climate signal in the amount of smoke that happened. But whether there's a climate signal in, if I light the same fires this year as I lit 10 years ago in Wisconsin or a given area, that's maybe a harder thing to motivate, a harder thing to defend. And as a scientist, we have to stay skeptical about these things, but also try to be honest about where the uncertainties are.
I want to tag on to that. I think as a manager, I kind of asked the question, the kind of smoke impacts we saw last year in Minnesota have never been seen before. And I think I can safely say that, at least back until before fire suppression, basically. And so the question that I ask from the climate is the frequency of this event, not this event specifically, because I agree with Jay, I don't think anybody ever proved that, but maybe they will. But is the frequency of this, is this something that, is this sort of like the floods? Is this a 1 in 100 year event? Or is the frequency of this, the likelihood of seeing something like this, is it more likely to happen? Or will I never see this again? And so those are the kind of things I think as managers to think about, because when I drove up, as I said, after later in the fall, after the millions of acres in Canada were starting to wind down, we got a large fire in northern Minnesota on the national forest. And when I remember driving up to that fire, looking at the plume, I thought I was driving out to a fire in California. I'd never seen anything like it. It was unreal. And I just sit here and think, in my series of slides that I have in my experience in my time, I've never seen that around here. And so is the likelihood that I'm going to see that kind of thing, is it more likely or not? I think those are the things that are interesting to think about, and to the degree that the climate people can advise us about that, I think that's useful information.
Yep, and I completely support and agree that those are the things that we need to be thinking about. And the caution is that even people who think about those sorts of, is this a once in a 100 year or a once in a 500 year event, or those sorts of assessments, there are fairly deep disagreements in how you even talk about the distribution of those sorts of things. Is that a sensible way of talking about that sort of event? In a certain context, it is. I mean, it's defensible and it's well represented in the literature, and it makes sense to talk about it that way. But if you get outside of that context, it gets gray and fuzzy in a hurry. It can for certainly that sort of terminology. And so it can, scientists argue about this stuff all the time. Obviously, that's what we do. That's what we're trained to do, is try to find weak points in each other's arguments and pound on them until the weak points are gone. But sometimes when those sorts of discourses find their way into the public sphere or the political sphere, or even when affecting policy, that's where things can get very tricky and very complicated. And so one of the things that I feel as a scientist is we have to be honest brokers here. We have to be very as clear as we can about what we're more certain about and what we're less certain about when conveying this information. And when terminology is being used outside of the proper context, we have to be clear that that's what's happening, and then say, okay, there's less certainty about this particular statement, but this is a way that we can go forward talking about it. And that would be my soapbox, if you will, or my advocacy about these sorts of discussions.
So I'm going to try to link our Fuel and Collaboration. We've had a variety of different series, and last year we had one that was focused on fire history, more from the oak perspective, and then just recently we had one with the mixed timber, and that's really looking at kind of the emerging fire history. And Trent, you kind of really got interested in that, as kind of that looking at that fire history information and frequency, and that the fact that smoke, we know when there's fire, there's smoke. Do you want to mention anything about that or your thought process with that, Trent? And thinking about the cultural aspects right now too.
Yeah,
Except
no,
it's a smoke.
I wanted to mention just that, I read a lot of scientific papers just because I'm a nerd that way, but I think some of the most earth-shattering scientific information I've read in the last long time is some of the stuff that's coming out now in regards to fire history investigations in my part of the world here in Minnesota, Wisconsin, and Michigan. If you look at some of the land fire data, some of the stuff that we get from out west basically says that fire is not a real player in the Lake States. I think people that work here know differently. And when we really get a real feel for how much fire was on the ground, because this goes into, and using it as a benchmark for an environmental analysis or trying to understand some sort of regulatory program, there's always this idea of we want to use a benchmark for what's natural or what's pre-European settlement or what's man-made. For example, the Regional Haze Program talks about we need to, what's the language here? Prevent impairment of visibility from man-made emissions. We have a wilderness. Wildernesses are supposed to be places where you don't see the influence of man. Okay, so what does all that stuff mean now when all this research is coming out talking about we're seeing that the amount of fire that was there pre-European settlement was way more than could have been from just lightning alone. And when you think about all the native, and it's obvious that's Native American burning that was going on, how does that affect obviously the amount of fire, how you look at it, what do you call it, and then how does that all come out in the wash? I think I had sent some posts, there's 3 within the last year, the same research group that's doing work up here, and I know some of this work is in other places, but it's really resetting, I think, the perspective of, I think a lot of people think natural and pre-settlement and all that was this pristine time of clean air where nothing was going on. And when you think about it, and you look at their evidence, there was a lot of smoke in the air back then. And if that's our baseline, if we want to pick a baseline and we use that kind of time period, our baseline is there was a lot of smoke. So when we get into some of these things that kind of hang us up on being able to do prescribed fire, like what's the assessment of putting smoke in a class 1 area? Ecologically, smoke was always in that class 1 area in a lot of places at a higher level. What does that mean? I don't know. These are new things. So it's just a fascinating new area of research. And I'd be curious the other panelists to talk about other areas where they work.
Thanks, Trent. Yeah, I agree. Here in our region, there are some class 1 areas, which are, for those of you who don't know, class 1 areas are those areas that are most protected from new and existing sources of air pollution. So there's just a lot of restrictions per the Clean Air Act on impacts to class 1 areas. So these class 1 areas, there are some in our region where prescribed fire is applied because we have those exact historical records, Trent, where it has always been on the landscape. It's not new. So.
Yeah, I love this line of thinking, and I think it's incredibly important for us to consider what our baselines should be. And I think in so many ways it can help us have an appropriate context, or at least an appropriate set of parameters for what we should expect going into the future. And there's a lot of different ways to go about it. You can take a map of historical fire regimes and associated vegetation types that currently exist now and apply that historical fire return interval, and then make approximations of how much smoke would have been produced. And there has been some work that has done that, but not enough. It's actually something that we're engaging in right now at University of Idaho. But I think that could help provide some context for not only understanding what to expect in future climate scenarios, but also, what our landscape actually, should potentially have as the amount of smoke that is appropriate for maintaining the ecosystems that we care about. And of course, there are always value judgments there. Which ecosystems do we think we can perpetuate into the future, given the climate change context that we're in? But I think having some kind of a baseline like that of, what if we wanted to maintain a set of ecosystems, what smoke should we expect to have on the landscape? I think that could help with some of the policy issues. And this was something I wanted to bring up to the rest of the panel and get your take on, which is, the idea of exceptional events, and that wildfires are classified as exceptions to the standards for air quality, and prescribed fires are not. And in many ways that hampers our ability to use prescribed fire, because it's not considered a natural event, something that can be an exception to the regulatory standards. What are your thoughts on that? And is that something that you also think gets in the way of our ability to use prescribed fire, and what can we do about it?
Lida, thanks for that segue, because I think that exceptional events can be a bit misunderstood. Prescribed fires can actually be considered an exceptional event if certain parameters occur. So I go over this a lot, and I'm sure Trent does too, when we teach our classes. We talk about these basic smoke management practices, and we also talk about state smoke management plans. So as long as a prescribed fire is lit under the conditions that are outlined in an approved state smoke management plan, or in accordance with basic smoke management guidelines, basic smoke management practices, rather, BSMPs, then should something occur where the smoke impacts a monitor so that it causes or contributes to an exceedance of an air quality standard, then it can be flagged by the state and approved by EPA as an exceptional event, and it can be flagged out. Just anecdotally from the southern region of EPA Region 4, they have not had to employ the exceptional events rule for prescribed fire in more than a decade. So that means that we're doing a really good job at employing fire without impacting air quality conditions at nearby air quality monitoring sites.
There's been it was really well said by Melanie. There's been a couple exceptional events, demonstrations made here tied to wildfires in my part of the country. So it's used, but I agree with Melanie. There's ways to fit in prescribed fire. And again, I don't think, at least in my part of the country, the air is clean enough that there's a background level that it's not probably going to be an issue with anybody around here. But yeah, I think again, it's those people in policy positions like at EPA and other things, and thinking about, what is your reference? What is your frame of reference? Thinking about national parks and wilderness areas as pristine and wilderness areas. And so we need to, their vision of what that is and looks like is probably different from what it really was in its pristine condition. And so if people are going to a wilderness, for example, and they see smoke and a fire, some people would think their experience was sacrificed or was a bad experience, where I would say, no, you saw the wilderness, that's what it is. So it's just a whole new way to think about it. But I know that's a tangent from exceptional events, but anyways, I just get worked up about that sometimes.
Oh, you guys nicely just like segued right in to the questions. We had a number of questions that were asking, what are the differences, or are there differences between wildfire smoke and prescribed fire smoke? So I don't know if you want to continue any more with that, or you certainly touched on it. Any more thoughts?
I would say no. Nobody calls the smoke prescribed fire smoke or wildfire smoke. We know in those situations, the fuel moisture and the loads and things can be different, but the way you calculate emissions is the same way Melanie's did. So there's no magic that a label gives to it. But I'll be curious to hear what other people say.
I thought that Jay's point about climate and climate change impacting fires was so applicable to that exact, to the exact question about prescribed fire versus wildfire smoke. You cannot make a blanket statement that one is more significant than the other. It really is, that's not a scientifically valid statement. Certainly conditions from a meteorological standpoint will impact smoke impacts, but as Trent said earlier, the math is the math. So.
Yeah, one issue I might raise about sort of the difference between wildfire and prescribed fire smoke would have to do with the intensity of the fire and the sort of plume rise and plume characteristics associated with putting the smoke into the atmosphere can be quite different. And that can affect how far the smoke is transported, if and when it comes back to the ground, and in what concentrations it comes back to the ground. And also from an emission standpoint, just the intensity of the fire can lead to changes in the constituents of the smoke as well. And that's more of a chemistry issue. And I try not to comment on that too much because, as I said, I'm not a chemist, but I know it's a factor. So all of those are considerations that can make the smoke behave differently, but it doesn't make it matter any more or less. It's just a different way of assessing where the smoke is going to go, where it's likely to build up, and who it's likely to impact. So I would support Trent's statement that smoke is smoke wherever it came from, and it all has to be considered. But in trying to assess the impact of even a whole bunch of prescribed fires compared to one wildfire or one large wildfire, that could be, even if it's the same number of acres, it could be very different sorts of impacts due to the way that the smoke transports and disperses.
Said that much better than I did. Thank you.
Well, go ahead, Lida.
I was just going to add, in regards to the biological contributions, because wildfires generally occur under lower fuel moisture situations where more fuels are available to burn, that the organisms that are exposed by combustion processes to aerosolization processes are very different in wildfire circumstances than in prescribed fire circumstances. So for example, permafrost soils that are now melting or thawing because of climate change are potentially exposing a whole different world of microorganisms to combustion and then therefore to aerosolization. So under certain conditions where more fuels are available and larger fuels are available, there will be a very different biological composition in that smoke when you compare those different burn conditions between wildfires and prescribed fires, just speaking very generally about those.
Excellent. You guys have mentioned, a number of times now, like tools or smoke modeling and smoke management. So I'm gonna pick on Melanie and ask her to kind of kick us off on that topic, thinking about smoke models and modeling, whether it's for prescribed fire or wildfire. We had a lot of questions that were more on the prescribed fire side and smoke modeling, smoke management.
Sure. So I have kind of a cheat sheet that I prepared for some folks on just how we look at assessing emissions and potential downwind impacts from smoke from your prescribed fire. And again, this is prescribed fire centric. And the first thing that if you're wanting to use a good screening tool to assess what your impacts are based on your planned meteorological conditions, these are the conditions that are set forth in your burn plan, then a good tool that's available on the web is VSmoke, VSMOKE. You can Google that if you're not familiar with it. It's developed out of the Southeast. But it's available and useful in a lot of areas, not in necessarily areas with significant elevation changes. So it wouldn't be useful in the Rockies, perhaps, but we use it in the Southern Appalachians all the time. So VSmoke is a good tool for burn planning. It's a screening tool. And then once you get into implementation, one web tool that is used around the country, I know Trent uses it all the time, is the Blue Sky Playground. So that is under airfire.org. Airfire, is it org or gov? But anyway, just Google Blue Sky Playground. And that is a really good tool for estimating not only your emissions, but what your downwind impacts might be based on currently forecasted meteorological data. And one thing that we are really focused on here in the Southeast is super fog formation. So we use a tool called PB Piedmont, also developed out of the Southern Research Station of the Forest Service, to assess the potential for nighttime smoke and superfog formation. And I'll let everybody else talk and talk about different tools as well, but I can share what the outputs would look like in PB Piedmont, because I think it's pretty interesting. Let me just share that really quickly, just so you can see what the PB Piedmont tool. This is a tool that you can. This is a tool that you can use on the web. Just Google PB Piedmont, and I just did a hypothetical burn on down in, I think this is in Mississippi, but these yellow dots and the red dots show the potential for nighttime smoke. Those are the yellow dots, and red shows areas where superfog might be a concern in the area. So we utilize this tool should the forecast indicate that superfog formation is likely, and we use the superfog matrix, which is found in a publication that I'll link into the chat.
So I can pretty quickly just tag on to Melanie that, there's tools are there. If you take RX410, you get a whole week's long introduction to them. One of the things that I've tried to do is figure out a way to get that information out to people who aren't spending a whole week in RX410. So with the help of Jack and others, over the past few years, we've put together a smoke tools class that's basically half to 2/3 of a day, where I can just go through just the tools and show you guys how to do them. Back in 2001, we used to be a major headache to try to get these tools installed on people's computers. It was a complete nightmare. But now, as computers get faster, we can do everything online. And again, these are tools that land managers can understand. They're not research tools, so they're ones again that give you the information you need, but don't require days of education. So again, I would promote that option. That again, we have these tools classes that we do, and then also one other thing I was going to mention is that there's a link on Jack's page of just where I've dumped a bunch of tools over the years as a kind of a place to go to look for some tools depending on what you're looking to do. But yeah, that's all I got.
All right. Well, what I would add to that, and this might come across as a little researchy, but there are some operational or even universally accessible aspects to what I'm about to talk about. But to my mind, as a research scientist, and there's also a bit of as a meteorologist, everything starts to look like a nail. But the applicability of tools, I would argue, for some of particularly the very local questions about smoke concentrations, is oftentimes limited by the quality and the detail in the meteorology that feeds into these tools. And that doesn't mean that the tools are useless. It just means that if you had perfect meteorology forecasts, the tools would get better. The tools would give you better information to make decisions on. Now, we all know meteorologists are never perfect, and we don't claim to be, but we're trying to get better all the time. But as Trent suggested, computers are getting a lot better at being able to generate local or the computing powers to the point where, I mean, I could probably sit down with just about anyone on this call for a week, and a week later, you would be able to do your own weather forecast if you could devote a week to it. I could teach you how to do that on just about any laptop that you're buying right now. It's possible. Now, how to interpret that and how to use that to make decisions is a lot more complicated. And that's why we have the sorts of tools that we do, and researchers working on this all the time to try to figure out how to mine that sort of information for decision-making information. But to me, one of the visions for the future, and whether this future is more in the 2 or 3 years or 5 years or 10 years, but is to have more and more on-demand, location-specific, high-resolution meteorology to drive the sorts of tools that we're talking about here, so that you can get hopefully more precise and more actionable information for what the smoke is going to do, and even what the fire potentially is going to do, and how to use that information. So that's one point that I would make, that's kind of the researchy wonky part. Now, The other part that I might mention is that there is a drive within federal meteorological circles, let me put that very broadly, to talk increasingly about providing weather services for fire and smoke applications. And there's a good amount of funding and a lot of resources that are being applied to this question, more or less as we speak. And myself and maybe several others on this call, or certainly several others that we know, are sitting on these committees and talking about what's the best way to basically lift everyone. Because the difference between someone who's sitting in North Ops in California and the type of technologies that they have at their disposal to address questions about fire and smoke can be very different than someone who's sitting in a remote office on the Huron-Manistee Forest, for instance, or something like that. And trying to figure out how to improve everything for everyone in the community, I would argue is a major component of these discussions about fire, weather, and smoke services going forward. So I don't want to be pie in the sky about this. We all know how government committees can and can't work, but the point is that those discussions are happening and trying to figure out how to leverage existing technologies and emerging technologies to bring more developed, if you will, or new tools to the sorts of people who are on this call going forward is happening, and we hope to see increasing action on this in the future. So I'll leave it there for now, but anyone that wants to talk about that more, I'd be glad to engage.
Well, that was kind of the segue into kind of our wrap-up question, at least from the questions we already have, which, describe what you guys see as the future of smoke management, smoke modeling. You just started mentioning that, Jay, about that future. Others want to jump in? I know Lida, you have the new research at the Pyrobiology. So thoughts?
Sure. So we are working hard now to try to develop what we're calling biological emission factors so that we could understand for a given fuel type what expectation we might have for both fungal and bacterial concentrations that are emitted under different burn characteristics. So that's going to be a long road ahead of us to develop those. As you all know, our emission factors, also took 30 years or so to develop and are still being measured in certain fuel types. So once we have those, we can do some modeling. At this point in time, we're using things like WRF S-Fire, a coupled fire atmospheric modeling system, and treating our microbial content as particulate matter. And since we have assessments of both in smoke columns, we can make estimates about what percentage of that particulate matter, if it was organic, how far would it go, and what communities would it impact downwind. So we're kind of at the beginning of that as well, but hoping to get more people involved in doing this research and get more information.
Others?
I can speak just a little bit. My crystal ball, I do think that there's going to be much more focus on firefighter health and safety from an air quality perspective. I don't know what that's going to look like, but I think that it has to happen. So that's my crystal ball.
I'll pick up on that one because I agree 100% with Melanie. We both talked about how the one unit in our class that deals with firefighter health has become the most popular unit. And I can remember in 2001, I don't think anybody paid attention to that unit. And specifically, one of the things that I've focused on personally, just because I've personally experienced it and seen it multiple times, is air quality in camps and fire camps. I think that's going to become a huge issue. I think it already is. We can stick our monitors in camps just as long as, just as well as we can stick them in downwind communities. And when, the idea is that folks are supposed to come back to camp to recover, not happening. And, there's solutions here that are easy. And one of the things is specifically carbon monoxide. And not, the fire is one thing, but there's carbon monoxide from all the diesel powered equipment that are very, are put in really dumb places. Nobody thinks about it. These are easy solutions. It's called get longer extension cords, people. But I've been in camps where those things are running right outside the yurts, and it's ridiculous. Been severely affected by that kind of stuff. So hopefully that stuff happens pretty soon. And I think, you know, in the long term, I think these tools are going to get so easy, you're not going to need people like Melanie and I anymore. Then I'll retire.
One other thing too, Trent, something that was said in our my ARCS 410 class last week, which is more southeastern centric. We have a lot of people in the South that, you know, do prescribed fire all throughout the fall, winter, spring, and then they go out west and do wildfires in the summer. So, Lida, to get to your point about allowing your lungs to heal, they're not getting any of that. So they're working, you know, 12 months a year in smoke. So we just need to think about those things and how we as an agency, or not just because I know this isn't just Forest Service, but we as a fire community, how that looks. So.
And I know I haven't been able to pay attention to the chat box, but I can see a lot of stuff that's being put in there, David and others on the team. Because we did have a question about, you know, quite a few questions about where can fire managers or other managers get information on and training in smoke. And I'm betting that there's a lot of links in that chat box that can answer that question. Why don't we transition right now then a little bit to some of the live questions. So Jen, if you're ready, if you want to pop on. And
Sure. Yeah, we've got a lot of questions. You guys have covered a lot of them really well in this discussion. But one thing that we got through the question option through emails from our registered attendees was someone was asking about smoke as an environmental justice issue, that we know that from some research that there's certain marginalized communities that are affected disproportionately by smoke. Can any of you speak to that, or maybe talk about how some of these tools can be used to mitigate or alleviate some of that impact?
I'll take a quick crack at it. I'm happy to say that when we put together, a colleague of mine put together a tool that actually basically incorporates a smoke modeling tool and some other things. He was a smart guy and he knew how to write R scripts, if anybody knows what that is. And he wrote an R script where he takes the results from the model of smoke modeling and overlays them on population tracks and some environmental justice data, demographic data. And the regional forester cited this as a really cool little thing. And, you know, where most of the work that I'm involved with doesn't touch urban areas, but it definitely touches tribal communities. And so, yeah, I think it raises that issue and is a good way to look at it.
Thanks. Anyone else want to jump in on? I know that's a big question. It's hard to tackle, especially with just a few minutes left.
Yeah, I guess my comment, and again, in some of the background research I did for the types of questions that were being posed today, I did come across a couple of papers that were talking about the demographics and the different types of smoke impacts that were happening on a national basis, that was looking for connections or relationships between smoke impacts and different types of communities, if you will. So there is definitely research that's going out that's going on, asking these sorts of questions and finding significant effects on disadvantaged communities. That was one of the conclusions of the study that I found. Tool development to address that is an ongoing issue. But another point that I would bring in from discussions that I've heard over the past 4 or 5 years, and this again might be a little bit researchy and wonky, but getting into the idea of artificial intelligence and machine learning and leveraging big data for understanding the impacts of smoke is an active area of research and potentially of tool development as well. I recall seeing studies a number of years ago of the the Twitter feed pipeline and using that to map out where smoke impacts were happening in some of the Northern California events where they had the hundreds of wildfires that were ignited over a certain time period, and being able to use that and even what we would, as a scientist, we would normally say very minor statistical differences in the types of messages that were coming out have huge significance for what it means for people and for areas, and being able to figure out how best to use that information and mine that information for understanding impacts and developing tools is something I see more and more of happening in the future. So I again have some hope that we can address these sorts of questions in a quantitative and in a policy-driven way going forward.
Yeah, thank you for that. That's very cool about the idea of big data with this topic, because I know we've seen some of that in other areas of fire, like fire and carbon and fire history. They're trying to get all these fire history sites together. Well, if we want to move on from that question, I had one more. We had a lot of questions from folks asking really specifically about weather conditions in their particular areas where they work. So in order to sort of touch on all of those, are there any hard, fast rules or universal rules for weather conditions that managers can keep in mind for smoke, either good or bad smoke conditions?
Boy, that sounds like a question for a meteorologist, and unfortunately, the answer is the short answer to that is no. There's no hard and fast rule. Everything is so location dependent, or so many of these questions are location dependent, that it kind of comes down to training. I mean, there's different levels of training. There's training yourself to understand what is important for your location, so a given manager, but also training the tools so that they have the sensitivities that are necessary to inform that understanding as well. And that's kind of what I was aiming towards, at least conceptually, when I was talking about these more increasingly location specific and detailed meteorological information becoming available. That's got to be part of this process, I would say, for improving this sort of understanding. Now, the other available, I guess, avenue of information for that today is, of course, the spot weather forecast that you get from the Weather Service. That's as the most widespread and available location-specific information you're likely to get, that most managers are almost always going to have access to. But the quality of spots and how one interprets a spot can vary from Weather Service office to Weather Service office and location to location. And to the extent that we're having these conversations about weather services and trying to make sure that they're trying to maintain the quality or increase the quality and sort of universality of weather services, I think that's part of the discussion as well, is how do we make them location specific, but also help really inform these sorts of discussions. So unfortunately, there's no easy answer to that. I don't think there's hard and fast rules of thumb. It's a complex ongoing process, unfortunately.
Yeah, complicated, but there are resources to help, I think, is a good take home.
Definitely.
Anyone?
I'm gonna stop here just for the interest of time. Do a quick wrap up. Thank the panelists for sure. My goodness, we could keep going for this for hours, but Andrea, kick it to you for a wrap up.
Yeah, I'm trying to not be I'm trying to be impartial here and not to say that this has been my favorite panel discussion so far, but it might be. I've really enjoyed this discussion. I think the unique experiences that each of our panelists have just contributed to this discussion in such a thought-provoking way. So I really want to say thank you so much to our panelists for your time and your energy and your participation. Jack, thank you so much for moderating this discussion. And to all of our participants for joining us today, for submitting questions and for helping to guide this discussion. We really appreciate your time. Before folks drop, just a few points I really want to make. Our next panel discussion is scheduled for Thursday, February 17th. We've got an excellent lineup. David Goodwin will be moderating. We have Fernando Garcia-Menendez, Steve Miller, Miranda Machrin, and Gary Wood slated as our panelists. So we hope that you'll come back. And with that, it's a wrap. So thank you, everyone.